Hello. Hi, my name is Thomas Kim. Today is June 19th, 2022. This is my fourth episode for C++ 17 2023 and other programming technologies. In this episode, I would like to introduce the easiest, the simplest C++ parallel library. They call it oneTBB. Wow, oneTBB. It is also called Intel Threading Building Blocks. Threading Building Blocks is very simple and easy to learn and to use. Intel Threading Building Blocks are fitting C++ for multi-core processor parallelism. Please double-click this link. This book is a bit old. It was first released in 2007, so it's almost 15 years old. But still, this book is very good. This book was written by James Linder. You can purchase second copy called ProTBB C++ Parallel Programming with Threading Building Blocks. Please double-click this link. Wow! You purchased this item on October 29th, 2022. I think I purchased this book before. Yes, I purchased 2 copies of this book. This book was written by James Linder. This book was published in 2019. If you scroll down, you can find a very good handsome man. His name is James Linder. And you can see someone left a review like this. This book is just awesome. Wow! I read C++ Concurrency in Action 2nd edition, and this book for TBB is pretty hard or challenging to program in low-level threading, but using TBB it's as simple as using C++ SDL. C++ Concurrency in Action helped me understand low-level threading, and ProTBB helped me understand high-level task-based parallel programming. ProTBB is a must-read for any serious C++ programmer. Someone called Chang-hee Kim left a review like this. My Korean name is Kim Chang-hee. Anyway, Intel ProTBB is just awesome. Very simple and very easy to use. If you remember just one thing, you are having a good start. Just remember SpinScoped MutexLock. SpinScoped MutexLock. SpinScoped MutexLock. SpinScoped MutexLock. SpinScoped MutexLock. SpinScoped MutexLock. If you remember these 2 words, SpinScoped MutexLock, you are having a good start to the world of parallel programming. SpinScoped MutexLock. SpinScoped MutexLock. SpinScoped MutexLock. Please memorize it. Commit it to your memory. Before you go to bed tonight, recite like this. SpinScoped MutexLock. SpinScoped MutexLock. Then you are having a very good start for parallel programming. I promise, at the end of this session, you will find an expert parallel programmer in you yourself. If not, you can show me jurisdiction, Daegu District Court, Republic of Korea or South Korea. I can stake my neck on it. You will find yourself an expert parallel programmer. Period. Exclamation. If you want to follow my current and future sessions, please watch episode 3 by clicking this link. In our previous episode, episode 003, we installed Intel oneAPI Threading Building Blocks. If you haven't installed, then you cannot follow my current session. Without further ado, let's get started. We need to make one minor settings. Right-click, search, environment, edit the system environment variables, control panel, environment variables, select include, edit, new, browse, this PC, system, or C drive, program files x86, Intel, oneAPI, TBB, latest, include, TBB. You have to select this folder. Click OK. Click New. Browse. This PC. System. Program files x86. Scroll down. Intel. oneAPI. TBB. Latest. Include. oneAPI. Select this folder. Click OK. These two passages are for Microsoft Intelligence. Click OK. Click OK. Click OK. All is set. Now start Visual Studio Code. Open CPP 17-20-23 Parallel. Just so you know, click this button. Here, type in C, C++. You have to install this extension package, this extension package, this extension package. You have to install these three packages for C++ Intelligence. Now, select this button. Click this one. 004 Parallel export.cpp. Hit enter. Ctrl V. I will make you parallel export. I will make a parallel export out of you. Include dog play fun. Output HPP. Talk play fun. S-stream. Print. Auto. L-value reference. And L. And L. Please remember, one carries return and flush out to console. What is important is flush out to console. Auto and L, I missed one. Talk play fun. Talk play fun and L, to carries returns and flush out to console. By flush out, I mean the memory or buffer travels from CPU, memory, or DRAM to the computer monitor. From CPU, memory to the computer monitor, there are stations such as DMA, GPU, memory, DAC, then monitor. It is a long haul, not this haul, or a long journey from CPU, memory to the monitor. Simply put, it's a very slow process. Here, DMA stands for Direct Memory Access Device. Here, DAC stands for Digital to Analog Converter. Now, void test simple parallel algorithm. Auto task 1, we create a very simple task like this. I will define int n 100 for auto I 0 I less than n plus plus I print. We can access this print. This print is defined in the global scope. Anything that is defined in the global scope, we can access in the lambda function. Task 1, I, and L. And L for flush out to console. A long journey. I create another task. Task 2. This is task 2. Now we run 2 tasks in parallel. How? TBB parallel invoke. Task 1, task 2, we execute 2 tasks in parallel. Task 1, task 2. Int main, I copy this function, paste it here. Please notice that print is global object, so we can access in the lambda. N is out of this scope. We cannot access n in the lambda. We have to capture. Okay? Now, in the command prompt, dir cd 004 parallel. I made typo. Export. I will fix the folder name, rename parallel. It's better. cd 004 parallel export. Now clang ++ SCD, we will use C++ 20 or 17, it doesn't matter. Okay? export.cpp, we need LLVM 12. Don't forget this switch. Or c.exe, hit enter. We built successfully. I will copy this for your reference. Ctrl V. I would paste it here. Now CLSC. There is some problem. Okay, there is some problem. We have to fix such problem. I would like to remind you one thing. Say, I don't catch n. I don't catch n. Instead, I would make n compile time constant like this. Contextful, then we don't need to catch. It is compile time constant. Let's try it. We build again. CLSC. The results are the same. Something wrong. Okay? Something wrong. Let's try with GNU compiler. G. The results are the same. Some problems. It is very simple, isn't it? We just create a task. We pass to parallel invoke. Very, very simple. But we have to fix this problem. How? Now, experienced parallel programmer. If you are experienced parallel programmer, you have to solve this problem using, please remember, SpinScoped MutexLock. SpinScoped MutexLock. Before you go bed tonight, SpinScoped MutexLock. Before you go to bed tonight, SpinScoped MutexLock. Before you go to bed tonight, SpinScoped MutexLock. Then parallel programming is simple. TBB, spin, mutex. We use mutex. Okay. This spin combines with mutex. So spin mutex. This mutex should be captured. L value reference. It should not copied. It should be L value reference captured. Mutex. Okay. Now we introduce scope. Local scope. Here TBB spin mutex. Please remember SpinScoped MutexLock. We have to copy this SpinScoped MutexLock. Okay? Spin mutex, then scoped lock mutex. It's very simple. Copy this. Also make block, paste it here. Then we are calling this function here. This is experienced parallel programmers toolset. SpinScoped MutexLock. I said, if you remember SpinScoped MutexLock, you are having a very good start for parallel programming. Now, we build this function like this. We build again. CLSG. Now, there's no problem. See? 2, task 2, then task 1, 1, 1, 1, task 2, 2, 2, 2, task 1, 1, 1. 2 tasks are interleaved. Okay? Task 1 and task 2 are interleaved. But the programmer who make parallel coding like this is not an expert. He is experienced parallel programmer, but not expert. First off, we use NDL for flush out to console. A long journey, a long haul, not this haul, this haul. A long journey, a long voyage. How do I spell voyage? Voyage. I forgot the spelling. A long journey anyway. It is not efficient. So we want to make it efficient like this. Talk, play, fun, NL. This is very simple. This is something like this. Nothing much like this. New line character. See? We removed long journey. Okay? We removed long journey. Instead here all strings, these strings are in buffer, in memory buffer. So after parallel algorithm, print and add. Now make a long journey. Empty the buffer or flush out to console. This way of programming is much more efficient than using NDL. Okay? It just writes to memory. It doesn't flush out. So this is more improved. We build again. CLS G. The result is the same. Beautiful. 2, 1 interleaved. You can say it's the same programming. Now this is experienced programmer, but he is not an expert. I will show you expert parallel programmer's code. This is expert test expert parallel programmer. Parallel programmer, expert parallel programmer, expert parallel programmer do not use synchronization constructs such as mutex and or locks. Instead, the experts find another way that dispense with synchronization constructs. See, I achieved the same result without using synchronization constructs. Let's see. Talk, play, fun, string, prints, 2. This is plural. We created an array. Okay, I will copy this, paste it here. This is true expert. Disable it. Expert parallel programmer do not use mutex or lock. Now watch it very carefully. L-value reference prints 0. Okay, we capture prints 0 as L-value reference, and we do not use this. Instead, we simply put new line here. Print 1. We do not use this, and so this print is print 0. This print is print 1. They are independent. There does not need any kind of synchronization. We do not need synchronization. Here, for or it should be L-value reference. Print. Now and there, flush out. Wow, this is magic. We never ever use mutex and or locks. These two tasks runs in parallel. We do not travel from CPU memory to DMA, direct memory access, or to DAC, digital analog converter. We never travel such stations. We travel only once. Only once. Now we will use clang this time. The results are the same. Clang, CLS, C, bingo, bingo, bingo. These are two different buffer, all working simultaneously with no error, with no bug, with no synchronization construct, without interfering each other anything. This is lock-free programming. I created string stream for such purpose. SpinScoped MutexLock. 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 SpinScoped MutexLock.